Number 1. Explain the advantage of writing a quadratic function in standard form. Well, it's easy to determine the location of the vertex when it's written in standard form. You can basically determine the vertex's location just by inspection of the form itself. Number 3. Explain why the condition of a not equal to 0 is imposed in the definition of the quadratic function. Well, if you had a equal to 0, you would have 0x squared plus bx plus c, which would, or you could have that. And that of course would be just bx plus c, which is the equation of a line. So it would no longer be a quadratic function. Number 5. What two algebraic methods can be used to find the horizontal intercepts of a quadratic function, also called the roots? You can use factoring or the quadratic formula. You can also use completing the square, alright, which the book doesn't cover, but I will be covering as an option in all of these problems. So you can see how that's done. That could be useful to you later. Number 7. For the following exercises, rewrite the quadratic functions in standard form and give the vertex. So for this one we have g of x is equal to x squared plus 2x minus 3 and I'm going to do this with two methods. The first method is the one that your book covers. The second is by completing the square, which I'm going to show you how to do, which we all were taught. When I say we, I mean my group of math students and the group that I taught as well. We were all taught how to complete the square. Okay, apparently they don't teach that anymore. I don't know why. It's a perfectly good method, and it shows some good mathematical ideas that could be useful to you later. So I'm going to cover both methods. If you only want to see the method you're familiar with in this book, just when you see me get into method 2, you can move to the next question. Okay, but if you want to see how to complete the square, I'll be doing that with each one of these problems as an optional method. Alright, so we have method 1, the book's method, negative b, which is perfectly valid, by the way. This is a good method too. Negative b over 2a. Okay, what's that? And that's where a equals 1, that's the leading coefficient, b equals 2, and c equals negative 3. Okay, so we've got negative 2 over 2 times 1. And that's equal to negative 1. Alright. And then we've got g of negative b over 2a. That's equal to g of negative 1. So for that, again, of course, you just plug in x equals negative 1 in the original function. Alright, and those two places, and then compute the result. You get negative 4. I'll leave the details to you. Alright, so this gives us the x-coordinate of the vertex, and that's the y-coordinate right there. So there's your vertex. Negative 1 and negative 4. So knowing the vertex, we can write g of x is equal to x plus 1. Where'd the plus 1 come from? It's always x minus, and then you write the negative 1, which becomes x plus 1 squared minus 4. You could call that y instead of g of x. Subtract the negative 4 from both sides, so it's y minus a negative 4 equals x minus a negative 1 quantity squared. Why write it like that? Well, that fits in with what we did in the transformations of functions section earlier on in the book. And you can see how this parabola, y equals x squared, will shift, right? You've got y, what did I say that was? Y minus negative 4 equals x minus a negative 1 quantity squared. So that negative 4 would move it down 4 units, all right? It's next to the y, so think y-axis. It's up and down, all right? So that moves down 4 units, and that moves to the left. Think x-axis is next to the x, horizontal movement. That moves to the left 1 unit. So you take y equals x squared, which is your parabola. There's y equals x squared. You move it down 4. 1, 2, 3, 4. And then you move it to the left 1. And there's your new parabola right there, right? So that's that fits right into the transformations of functions. Okay. So there you go. Now where did they get the negative b over 2a? 2a? Well, I will cover that at the end of this entire video presentation, right? When we get to after we get done with question 93, that's an optional bonus problem, or a bonus feature of this video. Okay, so I will show you how they got that. It's not too hard to follow, really. The book doesn't really tell you how, they just give it to you, okay? But you're completely able to understand it, so I'm going to cover it for you. All right. Okay, so that's method 1. Here's method 2. This is called completing the square. Again, this is the old school method, which we were all taught back in the day. Complete the square on this quadratic here, x squared plus 2x minus 3. That's what we're going to do. All right. So you write x squared plus 2x minus 3, and you group the x squared and the x terms together in parentheses, x squared plus 2x minus 3. All right. All I did was put parentheses around that. That's using the associative principle of addition. All right. If you want to get technical. And what I'm going to do now is take half the coefficient of x. So 1/2 times 2. That's half the coefficient of x. All right? Or in other words, that's half of b. And then square it. So you square the result. Half of 2 is 1. So that's 1 squared, which is 1. All right? Now I'm going to add and subtract 1 inside the parentheses. What am I doing here? And why am I writing equals? Well, take a look. Does this in fact equal that? Well, yeah, because I'm adding 1 and subtracting 1. All right? That's like adding 0. In fact, that's what we refer to that as adding 0. Why Would adding 0 help you solve a problem? Yeah, it's kind of a surprise, but it works. Yeah, adding 0, imagine that. It's kind of like multiplying a fraction by 1 if you want to change the denominator but not change the fraction, right? You just write 1 as whatever you want to get the denominator that you need. I usually do that with a common to get a common denominator. So this is kind of like the addition analog to that. All right, you're adding 0. It doesn't seem like you're doing anything. It's like multiplying by 1, but you are in fact doing a lot. Now what you do is you write x squared plus 2x plus 1 in parentheses. And then bring the minus 1 outside and add that to the minus 3. Now you might say, well, I really didn't need parentheses to do this. Yeah, true. But you will if the leading coefficient is something other than 1. So if that's the case, then you're going to need the parentheses. Okay, so I'm just getting you into the habit now. All right. So now what do we have here? This is a perfect square trinomial. Right? This is x plus 1 quantity squared, and then that becomes minus 4. Oh, we've seen that before, haven't we? Up here. Yeah, up there. So there you go. Now you can read the vertex right off. Now you might say, well, this first method's a lot easier. Well, yeah, in this problem it is. Yeah, I agree. But in other problems where you might get a more complicated quadratic, this will be easier because it'll be easier to evaluate, easier to write this than it would be to evaluate g of negative b over 2a. All right, if this is complicated with a lot of nasty coefficients, you know, or not a lot, but you know what I mean, if you've got some nasty coefficients up there and you don't want to mess with the calculations, then you can use completing the square and the answer pretty much drops right out. You don't have to do any of those computations that you would here. All right. Admittedly, this part here is probably pretty simple all the time, but this part is the harder part. Okay, the evaluating in the function. So, like I said before, also, it always helps to know more than one method to tackle a problem, because you never know when another method might help or might make the difference between solving and scratching your head over a problem. Okay, so it's always good to know something like this. And this principle here of adding 0 is something that you see every now and then in mathematics, in more sophisticated mathematics, like calculus. And it's good to be familiar with it right here in precalculus if you get a chance. And that's what I'm giving you here. Okay. Number 9, we have f of x equals x squared plus 5x minus 2. So here's method 1. All right, so negative b over 2a is equal to negative 5 over 2 times 1. And that's equal to negative 5 halves. And then we evaluate f of negative b over 2a. So that's f of negative 5 halves. And that equals, I think I'm going to write this out. Now here's a case where it's not too pleasant to evaluate this. Since it's a fraction, a lot of people are seem to be allergic to fractions nowadays. Alright, so you may not enjoy doing this. And you may make mistakes, who knows, if you're not well practiced at it. But I'm going to write it down in case you know, you need to do this if you're in a test situation or something. And this, in this case, I would do completing the square, personally. I'd use completing the square on this one. All right, but anyway, you've got negative 5 halves squared plus 5 times negative 5 halves minus 2. So this becomes positive 25 fourths. Then minus, you got 5 times negative 5 halves, that's minus 5 times 5 is 25 over 2 minus 2. Alright. And then we've got 25 fourths. Now multiply that fraction by 2 over 2 to give you the common denominator, which happens to be 4. Alright, so you're going to get 50 over 4. And multiply this by 4 over 4. That gives you 8 over 4. Now everything's got common denominator. So this becomes 25 minus 50 minus 8, which is negative 33 all over 4. All right. So then we have to give our vertex. The vertex, call it V, is negative 5 halves and negative 33 fourths. Okay, and then f of, or we already did that. So now we need to write it in standard form. We've got f of x is equal to x plus 5 halves quantity squared minus 33 fourths. All right. So here's method 2, that's completing the square. Alright, so you write x squared plus 5x minus 2, and then group x squared and the 5x in parentheses using associativity. Alright. Now you take half the coefficient of x and square it, and then add and subtract it. Alright? Half the coefficient of x is half of 5, and then you're going to square that. Alright? So that's 5 over 2 squared. And that's 25 over 4. So what you're going to do is add and subtract that number inside the parentheses. So you're adding 0, which continues to be equal, right? So x squared plus 5x plus 25 fourths minus 25 fourths in parentheses, and then minus 2. Now you bring the minus 25 fourths outside and add it to the negative 2, and that leaves you with x squared plus 5x plus 25 fourths minus 25 fourths minus 2. Alright? Now this will always be a perfect square trinomial when you use this method. That's why it's called completing the square. Alright? So what is this? This is x plus 5 over 2 quantity squared. You can either take half of this coefficient here, 5 over 2, or you could take the square root of that. That's also 5 over 2 to get that number, 5 over 2. Alright? However you want to remember that. So this is x plus 5 over 2 quantity squared. Alright? Hey, look at this. Where were we? Up here. There you go. As we expected, it's the same. And then you change that to 8/4 and then add it to that, or subtract it. Negative 25 minus 8, and that's minus 33/4. And we get the same answer, and there was no messing around with evaluating these fractions. Okay, there was just only this part here, which is comparatively a lot easier than doing all this, right? So again, if you know more than one method, it could save you a little time. All right, it's not that you can't do this. I mean, you know, you don't need to be afraid of doing that. Maybe you need practice in that, so you should do it that way. But what I'm saying is, if you're in a test situation, you have a time limit, use this method, right? It'll save you a little time, no doubt. And then you can use that extra time maybe to work on a harder problem. Number 11, we have k of x. K of x is equal to 3x squared minus 6x minus 9. So here's method 1. We have negative b over 2a equals negative of negative 6 over 2 times 3. So that multiplies out to 6, and that'll cancel that 6. And a negative of a negative is positive, so it's just 1. Alright, that's not too bad. And then we've got k of that. K of negative b over 2a. So that's k of 1. And that's not bad either. 3 times 1 squared, that's 3 minus 6 times 1. 3 minus 6 minus 9, which is negative 12. Alright, in this case I would definitely prefer the first method. Alright, completing the square on this will take more time and is a little more difficult. So on that one, I would recommend method 1 in your book, the same book method. All right. Well, this Vertex, by the way, I should write out what we're supposed to answer, right? So before I move on to completing the square, so the Vertex is 1, negative 12, and so k of x in standard form is 3. So the leading coefficient you put in front of the parentheses, and then you've got x minus 1, quantity squared, minus 12. Alright, so here's method 2. Again, I would not recommend this method for this problem. So, but this problem does introduce a little twist that we need to think about if you do use completing the square, because the leading coefficient doesn't equal 1. So it's a valuable problem for that reason. Alright, so don't turn your brain off just yet. You're going to see how to complete the square when the leading coefficient doesn't equal 1. Alright, so you group the x squared and the x in parentheses as usual. And then I want that leading coefficient inside to equal 1. Alright? Not negative 1, positive 1. I want it to be positive 1. If that were a negative, I would have to take care of that. Alright? But it's not. So I'm going to common factor a 3 out of these two terms. Alright? In the parentheses. Bring that in front. That leaves you with x squared minus 2x. Now if that happened to be a negative x squared minus 6x, I would write negative 1 in front. That would be x squared plus 6x. Alright, if you're factoring a negative 1 out. But I'm not doing that, of course. Alright? And then you've got minus 9. Okay, so this step must be done before you take half the coefficient of x and square it and then add and subtract. Alright? So you make sure that leading coefficient inside there is 1. Positive 1. Now you can take half the coefficient of x, I'll do it off to the side, half the coefficient, that's half of -2, and then square it. Now, really, in practice, you don't have to worry whether that's positive or negative, because when you square that, it's always going to be positive, all right? So I just wrote that for the sake of being correct, technically correct. But when you do it, like you could do that in your head, don't even worry about the sign. Just consider it positive because you're going to square it anyway. All right, and that'll save you some time as well. So that becomes -1. Half of -2 is -1, and then square that, you get +1. All right. Now you add and subtract 1 inside the parentheses, so you get 3x² minus 2x plus 1 minus 1, close parentheses, minus 9. Now I want to bring that -1 outside. However, I have a 3 multiplying everything inside the parentheses. So before I can bring out that -1, you just can't go -1 here like you did in the other ones, all right, the other previous problems. You have to multiply it by 3 and then bring it out. Okay, so this is equal to 3x² minus 2x plus 1. And then it's going to be 3 times -1 is minus 3 times 1, minus 9. So what I'm showing here is you're multiplying that -1 by the 3, and then you can bring it out. Okay, like that. You must do that step, otherwise it's not going to be correct. Okay, so you've got 3. Now this is a perfect square trinomial again, so you could take the square root of 1 or take half of 2. Alright, and since there's a minus here, you put x minus and then 1, quantity squared. And that's so minus 3 minus 9 is minus 12. So again, we get the same answer as we did before. Alright, but this is valuable for showing this little technique, or this thing to think about right here, where you have to get that 3 out in front and so forth and so on. Okay, so again, don't use this method for this problem, but it's a good teaching tool anyway.